Oh yeah, absolutely. All right, here we go. Let's take a look at this. We've dealt with angles like this before. Just tell me what kind of an angle that is.
Acute.
It's an acute angle. Very good. Okay, and then you kind of see where I'm going with this, don't you? Yeah. What do you think? That's an obtuse angle. Very good. And what do you think the next angle? Yeah, let's do a right angle. Okay. All right, so we're familiar with those, aren't we? I mean, we're really familiar with them. Oh, I know it's not. I was testing you. Not really. I just forgot it. Okay, very good. So you actually were paying attention, weren't you? Good. That makes me feel so much better. So that's a right angle. That's an obtuse angle, and this is an acute angle. So we have an acute, an obtuse, and a right. So what did I say before, my little introduction before I started recording this? What did I say we're going to be talking about the bunch of chapters? Triangles. So guess what? We're going to have a triangle with what? Acute angles in it, okay? I just happen to have a triangle. Look at that. Just happen to have it. Isn't that amazing? All right, let's take a look at this. Tell me something about all three of these angles inside this triangle. They're acute. That's an acute angle, isn't it? It's less than 90 degrees, right? So is that, so is that. So this is not brain surgery here, all right? It's not much of a stretch. What kind of a triangle do you think we call this triangle? An acute triangle. Very good. Okay, so we call it an acute triangle. Now, it's an acute triangle not just because there's one acute angle, not just because there's two, but because there's what? Three. Okay, we'll say all. Is that all right? All acute angles. So an acute triangle is when all three angles are acute, then it's called an acute triangle. Now what we're doing is we're classifying these triangles by their angles. All right, so I'm taking a look at the angles. What kind of angles do I have? I got acute angles, so it's an acute triangle. In a few minutes, we're going to talk about triangles according to their sides. All right, the lengths of their sides. But right now, we're just talking about their angles. You good with that? I bet you see where we're going with this, don't you? What do you think the next thing I'm going to talk about? Very good. All right, because I had an obtuse angle, don't you think that would be the next thing we're going to do? Yeah. But look at this. Now, on the acute triangle, I said that all three angles were acute. So on an obtuse triangle, are all three angles obtuse? No, that's not. That's right. Because watch, if I did this, this is a start, right, of an acute triangle right here. If I wanted to make an acute triangle, and if I said, okay, all three angles are acute, can I have a obtuse? Can I have a triangle when all three angles are obtuse? There's no way. Because look, if I make this an obtuse angle, is there any way that's going to be a triangle? No, because that gets further and further away than that side right there, doesn't it? Okay, and there's no way I can make a triangle out of that. And that's just two obtuse angles, isn't it? There's no way I can have all three and get a triangle out of it. The only way I can make a triangle is if I do that. You see it? So how many obtuse angles am I going to have? I'm just going to have one obtuse angle, and that's it right there. What do the other two angles have to be? They have to be acute. Does that make sense? So this is an obtuse triangle, so write that down. It's an obtuse triangle, and it's how many obtuse angles do you have in an obtuse triangle? You have one obtuse angle, all right? Not all three. You just have one obtuse angle. It's pretty easy to see, isn't it? All right. What do you think is next?
Right.
Yep. Let's put this right here. There we go. And I know what you're thinking. That's not a right triangle, is it? Until I do this. Now, think in the same way that we did up here. How many right angles can you have in a right triangle? You can only have one because, look, if I come over here, here's a right angle. I want to make a triangle out of it, right? Can I have another right angle? There's no way. All right, is there? Everybody see that? Because there's no way I can get a triangle out of that if I have another right angle in here. So there's just no way at all. So the only way I can get a triangle is if I connect from here to here. What are those other two angles? What's this angle and this angle right here? They have to be acute. That's right. So on an obtuse triangle, you have one obtuse angle and the other two have to be acute. It can't. Can you have an obtuse and a right? No, there's no way. Because watch, if I took this and went straight up, again, there's no way I can get a triangle out of that if I just go straight up here. You with me? Yeah. All right, Jacob, you getting all this? All right, head up, please. All right, so let's take a look. We call this a right triangle. How many right angles are in a right triangle? 1. So
Stop.
I'll just shorthand this. 1 right angle.
I told you to stop.
I'm not doing nothing.
I'm staring at me.
Look, 1 right triangle, 1 right angle. Everybody got it? Pretty simple stuff. All right, let's do another one. I don't think I have... Let's see, let me scooch this over a little bit. I thought I had one. No, I don't. Look at all that stuff. I got those sitting there just in case I need them. But the problem is, girls, please, let's do this. Let's draw, sorry, let's draw one like this. And what I'm going to do is I'm going to copy and I'm going to paste. So, what's true about this length and this length right here? Yeah, talk about the length. Let's actually, I forget what I just said. We're getting somewhere else. I want to do something else with it. Let's see. Did it rotate? Do I rotate? I think. Yeah. Let's go 60. Alright. I'm going to put that right. I'm going to put it right there. I'm going to make all equal. I'm going to make all equal angles. Right, because I'm dealing with the angles, right? I'm dealing with the angles. Alright, let's see if I can get this to work. Yep, there we go. That looks pretty, doesn't it? Isn't that nice? Oops, let's do this. And I'll group it. Okay. I want to show you something. Let's just talk about the angles right now. Look at this angle. Now, it's an acute triangle, isn't it? But it looks a little different than this. Because does this angle right here look the same as this angle right here?
Ryan Woolsey,
Now, that looks a little
Justin
bit...
Rushline,
In the middle of class.
please come to the office.
Okay, watch. Look at this angle right here. Does that look the same degrees as this? No, that looks steeper than that one, doesn't it? Okay, but look at all 3 of these angles right here. I actually made it so it would be like this. They're all actually the same degrees. So this angle is equal
Eric
to
Mears, please
this,
come to the office.
which is equal to this. Alright? So we have a name for that. Alright? And we call this an equiangular. Equiangular. Alright? So it's called an equiangular triangle. Of course, what do you think that means? Equa means equal, right? And then the angular is talking about the angles. So all 3 angles are equal to each other. All right, so that's another way that you could describe this. You okay with that? Yep, pretty easy. There's a couple examples, but they're pretty easy. I don't think I'm going to waste any time with that. Let's go to the next section. Now, we classified all these angles by, or sorry, all these triangles by their what? By their angles. By their angles. We didn't really talk about the sides at all, did we? All right. We only talked about the angles. I'll tell you what. I'm gonna save this one. And let me pause it. All right. Look at that triangle. That looks like the same triangle that I drew before, and we said it was equiangular. But did you notice how I made it? You watched me make it, right? So I took this side and I did what to it? I copied and pasted and put it here. I copied and pasted that and put it here. So what do you think is true about all 3 sides? They're equal to each other. So how can I show that they're equal to each other? We've done this before. The little tick marks, right? Tick marks, that's what we call them, okay? So right there, there, and there. So we know it's equiangular, but we also know, guess what what do you think you would call this? Equilateral, right? Equilateral, because lateral means sides. So it's equilateral. So it's an equilateral triangle. Now we're classifying these triangles by their sides, not by their angles. You with me? So we take a look at the sides, the 3 sides, and we say it's equilateral. Now look, it's the same exact triangle. What did I say earlier about this triangle? That all 3 what? Angles were equal. So tell me something about a triangle that's equilateral. It's also what? Yeah, well, we said it's equilateral, and it's also equiangular. Very good. Okay, it's equiangular. So you can't have an equiangular triangle and not have the sides being equal. They have to, both are going to be the same. You with me? So if it's equiangular, it's also going to be equal what? Lateral. If it's equilateral, it's also going to be Equiangular. Now look, this next part's free of charge. I don't even think they talk about this in the book right now. Free of charge, right? I won't charge you for this. It won't show up on your tuition bill, okay? All right, so it's just because this isn't officially discussed right here in this section, but I think you guys have probably seen this before. Do you know something about the sum of the angles of a triangle? 180 degrees. You probably learned that before, didn't you? Okay. So watch. If all three angles were exactly the same, that's right, each of these angles, that's why it's free of charge, because we're officially going to talk about this in another lesson, just not today. All right. So each of these, this is kind of like a preview. Isn't that exciting? Sometimes that's the best part of the movie, isn't it? The previews. All right. So look. So all those angles are going to be 60 degrees. We don't officially know that yet. All right. So keep that under your hat. Don't tell anybody I told you that. All right, so there we go. Let's keep going. Let's talk. So we talked about equilateral. Let's talk about a triangle. Let's make a triangle that looks like this. Sorry. I'll start off with the bottom. Let's do it right here. Okay, start off right here, and then I'll just kind of. I'm not going to get perfect on this, but yeah. Never mind. Okay. Actually, I'll try to make this nice. Transform, reflect. There we go. So what did I just do to that left side right there? I copied and pasted, right? So what's true about these two sides? They're equal to each other. Now, I try to make it a little more obvious. Now, this side is equal to this side. Do you agree? You saw me do it, right? I've hit Control-C, Control-V. That's copy and paste. Everybody know that?
Yeah.
Okay. So those two are equal. Does that look equal to these? No, and it's not. So only two sides are equal. We have a name for that. You've probably heard this word before too. That's right. It's isosceles. I'll write it down here. Isos, I-S-O-S, C-E-L-E-S. Isosceles triangle. Isosceles triangle when two of the sides are equal. When two sides are equal. Up here, it's equilateral when what? All sides or three sides are equal. You follow me? Equiangular because all three angles are equal. You get it? So isosceles when two of the sides are equal. Now technically, let me just say this. Technically, if you look at the definition says at least two of the sides are equal. Well, then if at least two of the sides are equal, we could also call this triangle what? Isosceles, because there's at least two sides equal, right? It means two or more. But for the most part, we usually just save the word isosceles when exactly two sides are equal. But technically, the technical definition is that at least two of the sides are equal. But for the most part, we look at this and we say this is isosceles and we say this is equilateral. Does that make sense? But I could say this is isosceles as well, but we hardly do. We usually just save it when only two of the sides are equal. Make sense? We're going to do a lot more stuff later on, knowing that these two sides are equal. We're going to compare the angles to them and all that kind of stuff. We'll talk about that at some other point. All right. Here's one other triangle. Yes, it's getting close. All right, so watch. Here's another triangle like this, and like I'm trying to make it so that it doesn't look equal. You know why? Because that angle looks too much like a. Let's do that. Let's do that. There we go. Yeah, those sides don't look equal, do they? All right, so none of the sides are equal. We don't use this very often, but I just throw this out there. If none of the sides are equal, right, we call that a scalene triangle. All right. Again, there's really no there's no theorems, there's no postulates, there's really not much that talks about scalene triangles. But scalene triangles, what? No sides are equal. Okay. Let's do a quick example, and we'll be done. All right, here's the problem. This is an example. I think this is the only example we're going to do. Yes, it is. And they ask you to find the lengths of all three sides of the triangle. So we'll call this ABC. I want to find length AB, BC, and AC. All right, this is what they tell you. Well, look, what kind of a triangle is this? It's isosceles, isn't it? Two sides equal. So what's true about this side and this side? They're equal. So what are we going to do with those two? Set them equal to each other. So 4x plus 1 equals. Now, isn't that very similar to what we've been doing? Absolutely. Okay, it's just not angles. Watch. Minus 4x, which is an x, equal, add a 5, 1.5. So x is 1.5. Is that what I asked, though? No. So what do we have to do to find the length of this side? Plug it into it. So 4 times 1.5. Somebody do that. It's 6, isn't it? 6 plus 1 is 7. So that length right there is 7. So what's this length without doing any math at all? 7. Plug x into there, figure out what it is, and I can't finish it.